Hello students, we shall learn about the terms used in the extraction of the metals and concentration of the ore in today's session, that is from the metallurgy topic. So before that, let us recap what we have done in the earlier session. We have studied about the properties of the metals, that is they are shining in nature, which is called as lustrous in nature. They are good conductors of electricity and heat, and they have high density and melting point. They are malleable, that is they can be molded into any shape, that is thin sheets they can be made. And they are ductile, that is they can be drawn into thin wire, and they are solids at room temperature except mercury, and they are also opaque in nature. We have also discussed about the properties of non-metals, which are all opposite to what we have discussed for the properties of the metals. In today's session, we shall know the terms in the extraction of the metals and the concentration of the ore. So the basic terminology of the metals are: it is a domain of material science and engineering that studies the physical and chemical behavior of metallic elements, their intermetallic compounds and their mixtures, which are called as alloys, and the process of extracting a metals in pure form from its ore is known as metallurgy. And let us also know what is a mineral is. A mineral is a solid, naturally occurring inorganic substance formed by geological process. An ore is a naturally occurring solid material from which a metal or valuable mineral can be extracted. Now let us look at some of the metals and their ores. Here, sodium, aluminum, potassium, and magnesium are the metals, and let us look into the ores which they are available. Sodium is present in the ore like chyle, saltpetre, torna, borax, common salt. In all these four, sodium metal is found. Aluminum is found in the form of bauxite ore, corundum, feldspar, cryolite, alunite, kaolin. So, in all these six ore forms, aluminum is available. Potassium is available in nitrite, that is saltpetre, carnallite. Magnesium is available in magnesite, dolomite, Epsom salt, kieserite, carnallite. So these are some of the metals and their ores. Now let us look into what is a flux is. It is a chemical cleaning agent used for purification of the ore. Flux in metallurgy is any substance introduced in the smelting of the ore to promote fluidity and to remove objectionable impurities in the form of slag. Flux in metallurgy is any substance introduced in the smelting of the ore to promote fluidity and to remove objectionable impurities in the form of slag. Limestone is commonly used for this purpose in smelting iron ores. Other materials used as fluxes are silica, dolomite, lime, borax, and fluorite. So, flux is defined as the substance used for removing the gangue from the ore in the form of slag, which is called as flux. There are two types of fluxes, acidic flux and basic flux. Acidic flux is used to remove basic impurities and basic flux is used to remove acidic impurities. So basic flux, let us look into it, what is a basic flux is and acidic flux is. So here FeO is an ore which contains basic impurities. So for that acidic flux is required. So here acidic flux used is SiO2 which converts into FeSiO3. Similarly, SiO2 is an acidic impurity, so basic flux is required. So in this way acidic flux and basic fluxes are used to remove the gangue or the substances present in the ore. Next, coming to slag. The waste material separated from the metals during the extraction of the ores are called as slag. The fusible products formed by the reaction of flux with gangue during the extraction of metals is known as slag. SiO2 plus CaO gives rise to CaSiO3. Similarly, here the slag is a fusible material which is removed. Coming to what is a gangue is earthly impurities including silica, mud, etc. associated with the ore are called as gangue or matrix. In mining, gangue is a commercially worthless material that sounds or is closely mixed with an unwanted material in an ore deposit. It is thus distinct from overburdens, which is the waste rock or the materials overlining an ore or the mineral body that is displaced during mining without being processed. Now let us look into the concentration of the ore. Ore dressing or concentration of the ore. The ore usually contains large quantities of impurities like earthly matter, rocks, stones, mica, feldspar, etc., which is known as the gangue or the matrix. To remove these impurities from the ore dressing or concentration of the ore is done. So, concentration of the ore is nothing but removing impurities from the ore. So, during ore dressing, percentage of the metal decreases, so it is known as the concentrate. The purified ore is known as the concentrate. Definition of concentration of the ore. The concentration of ore can be defined as the chemical process of eliminating impurities like sand, rock, silt, grit, etc. from the ore for the extraction of metals. In a simple words, the concentration of the ore is the method of separating ore from the gangue. As the gangue or matrix are the valueless substances that are no use, so they have to be separated out. So there are different methods, physical and chemical methods, to concentrate the ore. The ore which is obtained after the completion of the ore concentration is referred to as the concentrate. So removal of the impurities soil, sand, stone, silicates, etc. from the mines is known as the concentration of the ore, and the impurities are called as gauge. So, concentration of the ore is also known as enrichment of the ore. So, there are different ore dressing methods or the operations followed. One is hand picking method, second one is gravitation separation, third is electromagnetic separation, froth flotation process, etc. are some of the methods that are followed. Hand pricking method is, in this method, hand pricking is used to separate undesirable substances such as small pieces of the stones from wheat, rice, and pulses. As we all know, the hand pricking method. Similarly, this hand picking method also is used to concentrate the ores. So here the pieces of stones are picked up from the grains and by hands one by one and thrown away. Similarly, ores also, in the ore also certain things are done, impurities are removed. So in this way you can have a pure concentrate of the ore. Then next, winnowing is also one of the method. In the winnowing, in this method, heavier components of the mixtures are separated from the lighter substances with the help of wind. This method is used for separating grains from the husk after the process of threshing. Threshing is the process of separating grains from the chaff. In lavigation, it is also referred by gravity separation or lavigation. In the hydraulic wash, this is an hydraulic wash, the ore is separated from the gauge by the principle of gravitational force. The ore is first crushed into fine particles or powdered form, then the powdered ore is passed through the current of water. So you can see the hydraulic machine. Here it is made into fine ore particles, then a current of water is passed into it and it is washed on the well-fed table. So this is called as hydraulic wash. As the ore is more substantial than the gauge particles, it will leave behind and the gauge will float away through the stream of water. The process of hydraulic wash is accompanied by hydraulic classifier or Will-Feb table. This method is widely used for the concentration of oxide and carbonate ores. Next, coming to froth flotation method. In this process, finely ground ore, or we can also say pulp of the ore, is passed into the bioreactor along with a little oil. So oil is added to the ore. The oil which is generally used in the froth flotation process is pine oil. The bioreactor contains water into which the mixture of ore pulp oil is added through an inlet. Then the mixture of the ore, oil and water is thoroughly mixed and agitated by the rotating paddle, which comprises of impellers that allows proper mixing of all the components. There is constant airflow inside the medium, which leads to the formation of mineral froth that appears as a supernatant. So, on the top, we can see the froth or foam present after all this mixture is agitated. The froth contains mineral particles which can be collected by transferring the mineral froth into the other bath, where onto the bottom the ore free from the gangue will settle down. You can look at this froth flotation process. Here the pulp of the ore and oil are passed and they are rotated, and after some times a froth comes out on the top which can be removed. After settling down, a pure ore is separated out from the gangue. So the process depends on the fact that certain minerals are wetted by oil while gangue is wetted by water. Mainly this process is used for the concentration of sulfide ores of copper, lead, zinc, mercury, etc. The grounded powdered ore is taken into a big tank. To this, the mixture of water and small quantity of turpentine oil or pine oil and suitable additives like Na2CO3 is added. The compressed air is passed so that the ore particles sticks to the oil particles and comes out on the surface of as foam and is collected. The impurities like earth matters, rocks, stones, limestones, mica, etc. are wetted by the water, becomes heavier and settle down at the bottom of the tank. By using this process, the sulfide ore of copper, zinc and lead are separated from the impurities. So this method is mainly used to concentrate the sulfide ores. Next, coming to pyrometallurgy, which is classified into three categories: calcination, roasting and smelting. Coming to calcination, calcination is heating to high temperature in the absence of air or oxygen. That means we are heating the ore in the at a high temperature in the absence of oxygen. The main purposes of this calcination of the ore is to convert carbonates and hydroxides into oxides. So, if you consider ZnCO3, there is no oxygen. If you heat it, it is converted into ZnO plus CO2. And similarly, CaCO3 is converted into CaO and carbon dioxide. Similarly, AlOH thrice is converted into Al2O3 plus 2H2O. So, calcination is the process of heating the ore in the absence of oxygen. So, the purpose of calcination is to remove volatile impurities and to remove moisture and to make the mass porous. Now, coming to roasting, the process of strong heating of the ore in the presence of excess amount of air below its melting point. So here roasting is in the presence of air or oxygen. So here the purpose of roasting is to convert sulfides into oxides and sulfates to remove impurities like sulfur, arsenic and tin, and also to remove the moisture present in it. It is mainly used for the sulfide ores to convert the sulfides into oxides. And there is a lot of difference between calcination and roasting. Calcination, coming to calcination, it's a process of heating in the absence of air, and roasting, it is the process of heating in the presence of air to oxidize the impurities. Calcination is employed for carbonate ores and roasting is employed for sulfide ores. Calcination provides carbon dioxide along with the metal oxide, and roasting produces sulfur dioxide along with the metal oxides. Now let us look into the similarities of these two methods. Both are process of heating the ore below its melting point. Both aim is to remove the impurities in the ore. Now coming to smelting. Smelting is a form of extracting metallurgy. Its main use is to produce a base metal from its ore. Smelting makes use of heat and a chemical reducing agent to decompose the ore, driving off other elements as gases or slag and leaving only the metal base behind. The reducing agent is commonly a source of carbon such as coke or earlier time charcoal. So if you look at this process of smelting, carbon reacts with oxygen to give CO, burning of the fuel to give CO. Similarly, Fe2O3 reacts with 2CO, carbon dioxide, carbon monoxide to give iron plus CO2. So coming to alloys, alloy is a combination of metal or metal combined with one or more other metals. So alloy is a combination of metal or metal combined with one or the other. The purpose of alloying: strengthening of the ferrite, improved corrosion resistance, better hardening ability, grain size control, improved mechanical properties like durability, strength, toughness, etc. Improves cutting ability, better wear resistance. These are the purpose of alloying. The sum of the alloys that are used prepared are nickel steel, chrome steel, chrome nickel steel, chrome vanadium steels, manganese steel, silicon steels. As the name indicates, nichrome, it is an alloy that primarily consists of nickel and chromium. It is not uncommon for nichrome alloys to allow iron and certain other elements. The typical composition of nichrome alloy is nickel is 80 to 85%, chromium is 15 to 20%. Iron and other elements are very less comparatively. The primary application of nichrome is the resistance wire. It is also used as an heating element and in certain electrical appliances such as heaters and toasters, etc. It can also be noted that nichrome alloys are also employed in the dental fillings. Coming to chrome nickel alloys, carbon, nickel, chromium are the compositions. Carbon is 0.35, nickel is 1.25, and chromium is 0.6%. Chrome nickel steel will have, after heat treatment, almost the same strength and ductility as 3.5% nickel steel, which has also been treated. So, these are all about alloys.